Hiya, ninth graders. So we're moving on today. We've talked so far about multiplication and division of radicals and how to simplify those radicals down. Today we're going to finish up with our most difficult operation with radicals, which is adding and subtracting radicals. So here's a practice problem that is kind of the general idea. The triangle shown below has a perimeter of 6.5 square root of 2. Make a conjecture about how this answer was reached. A conjecture is an educated guess. So I'm going to go ahead and pause right now and write out your best guess to what do you think, how do you think they came to 6.5 square root of 2 as the perimeter of this triangle? Hopefully you mentioned something along the lines of adding all the side lengths up because that's how we find perimeter. All the side lengths here are 2 square root of 2 plus 3 square root of 2 plus 1.5 square root of 2. When we're adding and subtracting radicals, there is a key important piece. All radicals need to be exactly the same. We cannot add or subtract inside of the radical. We can just only add or subtract how many radicals we have. So here we have 2 square root of 2. We can think of that as we have 2x plus, and then we have 3 of those square root of 2 guys. And then we have 1.5 of those square root of 2 guys. Adding all of those pieces together, we get 2 plus 3 plus 1.5. That's 6.5x. In other words, we have 6.5 square roots of 2. And that is how we got to the perimeter. Now, it won't always be as straightforward as this, of course, because we're in accelerated. Sometimes it needs a few more steps before you can get to the final completion of your problem. So for instance, the sides of a triangle are 4 square root of 3, square root of 12, and square root of 75. Make a conjecture about how to determine the perimeter of this triangle. So if we wanted to add these side lengths together, how would we do this? What do you think our first step is going to be here? So remember that the key point is that all radicals need to be exactly the same. And the way that we can try and figure that out is by simplifying all of our radicals down. Now, 4 square root of 3 is perfectly simplified, so we can keep that in our expression. However, square root of 12 can be broken down into 4 times 3. And 4 is our perfect square here, and it can come out. Just realize that when it does come out, it becomes 2. And then what's left inside is the square root of 3. Square root of 75 is not a perfect square, but there is a perfect square that goes into it. The perfect square is 25. So you can think of this as 25 times 3. 25 will come out and become 5. And then all of the non-perfect squares have to stay inside, which means that your 3 stays inside. Once you simplify down these radicals, then you can add these coefficients together. 4 plus 2 is 6, plus 5 is 11. So we have 11 square roots of 3 for our perimeter. Now we don't have any units here. They didn't give us any units, so we won't give any units back. But if they did give us units, we should probably keep those on there. You could even here just say units, if that makes you feel better. All right, I would like for you to try number 3 on your own. This one's pretty straightforward. We have 1 square root of 6 and 3 square roots of 6. They combine together to be 4 square root of 6. All right, go ahead and try number 4 on your own. This one's a little bit trickier because we don't have all of the radicals to be the same. So you can only combine radicals together if the radicals are exactly the same. So we have different like terms. In terms of combining like terms, we have 2 different ones. We have the square roots of 2 terms. We have the square roots of 3 terms. And then we have the non-square root terms. And they cannot add together if they're not the same type of term. So we're going to add the things that are alike together, and then we have to leave everything else separated. So 7 square root of 2 plus 6 square root of 2. Make sure to always include that sign that's before the coefficient. So we're going to be adding these guys. So that becomes 13 square root of 2. Now we've got positive 4 square root of 3, and we're subtracting 5 square root of 3. Subtracting because the sign in front of 5 is a minus. So we've got 4 minus 5, which is negative 1, which I could just leave without the coefficient in front. So it just becomes minus square root of 3, which we know is just 1 square root of 3. Now that we've combined all of those like terms, we have our last term, which is plus 8. We have no more like terms, and so this is your final answer. All right, go ahead and try 5 on your own. Our first step with problem number 5 is that we need to simplify the radicals. Square root of 8, 4, is a perfect square, so that 4 comes out and becomes 2. The square root of 4 is 2, so 2 comes out. And since it was 4 times 2 inside of this radical, we're left with the square root of 2 on the inside. 32 has a 4 that goes into it. So here's a thought process. We have 4 times 8, but realize that 8 also has 4 in it. So you can think of that as 4 times 2, just breaking that 8 down into 4 times 2. These two 4s can multiply together to be the 16 times 2. So 32 can be broken down into 16 times 2. And 16 is a perfect square. It comes out to be 4. So when this guy comes out, it becomes 4, and we're left with the square root of 2. Once we've simplified down each of those radicals, then we can combine their coefficients as long as they have the same radicand inside. We have 2 of these guys and 4 of these guys, so they combine together to be a total of 6 square roots of 2. In other words, 6 root 2. All right. Last one. Square root of 12 simplifies down to 2 square root of 3 minus 48 has 16 that comes out of it, and that's going to be 4 square root of 3. Subtracting those out, we get negative 2 square root of 3 because 2 minus 4 is negative 2. All right. I'm going to go ahead and number these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it says, circle the expressions that can be simplified using the distributive property. Be prepared to explain your choices. Now, what it means here is by the distributive property is that really what you're doing when you are adding or subtracting these radicals together is that you anti-distribute. In other words, you take out the greatest common factor, and the greatest common factor is the square root of 2. Now, I'm going to put it at the end just because we know that at this point that radicals kind of go to the end. So that's why I'm going to put it here instead of normally when we take out the greatest common factor, it goes in the front. But here I'm going to put it in the back because we know that the radicals tend to be at the end. But still, I'm taking out that square root of 2 as my greatest common factor, which means I divide it out of the first term and I divide it out of the second term. 2 square root of 2 divided by square root of 2 just becomes 2. And then 4 square root of 2 divided by the square root of 2 just becomes 4. And this is what it means by the distributive property, is that really what you did was anti-distribution, in other words, factoring, to take out greatest common factor, square root of 2, and say, oh, well, then that just becomes 6 square root of 2. So that's your distributive property. So I would like for you to go back to this, make sure that you've numbered all of these out, and I would like for you to tell me which of these, click all the ones that are correct, which of these can be combined together to make, to be fully simplified down. If you cannot combine them together at all, then you would not click it together, but if you can combine it together even just a little bit, even if a couple terms add together but not all of them, you're still simplifying it down using the distributive property. So click all of the problems, all of these numbers that can be simplified just even a little bit by combining like terms. Hopefully here, what you said is that problem number 1 can be combined together. We've got the square root of 2 and the square root of 2, so those can combine. This guy cannot combine together because 13 is a prime number and 6 doesn't have a perfect square that comes out of it, so it just has to stay there like this. This guy can combine together because if you simplify the square root of 5, that becomes 3 square root of 5 because 9 is your perfect square that goes into that and it comes out to be 3. Number 4 can also be simplified just a little bit, not fully, because you've got your square roots of 7 here and here, so you can combine just a little bit. This guy can also combine because 2 square root of 8 simplifies down to 4 square root of 2, and then you can combine them together. 4 square root of 2 happens because I know that 4 comes out of here and becomes 2, and then it multiplies with the 2 in the front to become 4. This guy cannot combine. Oh, so these guys can combine. This guy cannot combine. This guy can combine because this simplifies down to 2 square root of 3, and this guy simplifies down to 5 square root of 3, which means they could eventually combine together. This guy becomes 4 square root of 2, which means that these two guys can also combine together. And these guys, this might have been a little bit tricky, but they cannot combine together. Even though we see that 26 has 13 that goes into it, it becomes the square root of 2 times 13, and neither of them are perfect squares. So you can't simplify that down. And 4 doesn't go into it, and that's it. Those are the only ones that can combine together. 1, 3, 4, 5, 8, and 9. All right. Is the following statement true or false? Try a few examples to test your answer. I would like for you to think about it for a second. Try out a few examples and tell me whether you think this guy is true or false. Just picking some random numbers that I like to work with. I might pick something like the square root of 3 plus 4. Now the square root of 3 plus 4, I could just put into my calculator. It's the square root of 7, which is 2.65 about, versus the square root of 3 plus the square root of 4, which is, you can see that I'm just typing it into my calculator there, square root of 7, square root of 3 plus the square root of 4. We see that that rounds to 3.73, which are not the same. Since a little dyslexia coming out, there we go. Since 2.65 does not equal 3.73, we know that this is not true. In other words, what we call false. All right, guys, great job today.